So mass spec questions fall into two broad types. The first is pretty much focused upon isotopes, and then we move into organic chemistry, where we learn how to identify the structure of molecules in certain cases based on the fragments into which they split in the mass spectrometer. So we'll start off with isotopes. First one could actually have done all the way back at the start, although right at the start of the course talking about 6 isotopes might have been a bit mean. But anyway, 6 isotopes for osmium, outstanding element, and natural abundance given in brackets. So all we do is we take the weighted average of these data, where we take for each isotope its mass multiplied by its percentage or its natural abundance, and then divide by 100 because these are given to us in percentages. Personally, I prefer to work in fractions, so instead of 1.59, this would have been 0.0159 and so on. In that case, we don't have to divide by 100, whichever floats your boat really. So anyway, pop that in, the atomic mass 190.2. Making it a little bit more sophisticated and actually bringing in the mass spectral data. The mass spectrum of Iridium, another awesome element, contains 2 peaks. So in other words, 2 isotopes. One has a mass of 191, the other one has a mass of 193. And I give you the heights there, 59.49 and 100. Now this is of course the big difference between this question and the first question. First question I gave you straight off the natural abundances. However, in this question here, I give you the relative values, but you got a height of 100 for the base peak, the other one 59.49. Obviously 100 plus 59.49 do not add up to 100%. So we have to determine the natural abundance simply by reducing the 59.49 and the 100 so that they are both percentages and add up to 100. So for the 191 peak, the natural abundance is the 59.49 divided by the 100 plus 59.49. In other words, what fraction does this 59.49 for this isotope make of the whole data? And for the 193 peak, same idea, except there of course it's 100 instead of 59.49. One should point out of course that these have to add up to 1, as I'm now dealing with fractions instead of percentages, so therefore I could have just taken 0.373 away from 1 to get to 0.2627. Either way, again, whatever floats your boat. Pop in these data now. So 191 times 0.373 plus 193 times 0.627 gives us the atomic mass of 192.2. Now when we move to considering mass spectra of molecules, a lot of times we have to worry about the isotope pattern. And so for PBr3, we get these different peaks here that fall into 5 nice sets. Okay, now phosphorus is one of those elements that occurs with one isotope with 100% abundance, and that is P31. So thus this one peak at 31 is just for the phosphorus that's had all the bromines knocked off it, and it's only one peak because there's only one abundance. Then we get to set 2 and we see there's 2 peaks separated by 2, and so that's probably an indication that this is an isotopic pattern right here. And we look for bromine, and bromine of course, as you learn in your A-level studies, has 2 isotopes, 50% abundance each, that way 79 and 81. So there is the 79, there is the 81, and as we said, they're equally abundant, so we'd expect a 1-to-1 ratio. So everything now on, we're going to have to worry about these bromine isotopes, which of course we didn't have to worry about for phosphorus because it is 100% abundance. So now we get to set 3, we got 110 and 112, and I hope you would see that 110 is 31 plus 79, and 112 is 31 plus 81. So in other words, these are just peaks for a PBr. Some of them have got 79 Br, that's the 110. Some of them have the 81 Br, that's the 112. Again, 1-to-1 ratio because you got equal number of 79 Brs and 81 Brs. Now we get a little bit more fun. 3 peaks, 189, 191. 193. So again, we can immediately recognize that 189 is 110 plus 79. 193 is 112 plus 81. So what we're doing in set 4 is we're just getting another bromine into the action. So they're all PBr2 peaks. Now, why do we have 3 peaks for it? Well, the 2 bromines can either both be 79, so that would be 79 plus 31, which is 189, or one could be 79 and one could be 81, so 79 plus 81 is 160, plus the 31 for the phosphorus is 191, or both of them can be the heavier isotope. They can both be 81, so 2 of those is 162, plus 31 is 193. Now, why would this be a 1 to 2 to 1 ratio? Well, because of the normal type of splittings that you get, the normal type of ratios, the normal type of probabilities, however you want to think about it. For this BR2, 79 BR2, both of them are 79. So the first one is 79, the second one is 79. For the 81 BR2, both of them are 81. So the first one's 81, the second one's 81. For this one here, the first one can be 79, in which case the second one's 81, or the first one can be 81, in which case the second one is 79. So 2 possible ways to make this one possible way to make each of those sort of 1 to 2 to 1 ratio. Finally, for peaks at 268, 270, 272, and 274, well, all that can be left, we've done P, we've done 1 bromine, we've done PBr, we've done PBr2, so these must be PBr3 peaks. So now what we're doing is looking at how many different ways there are to have 2 isotopes spread across 3 bromines. So obviously we can have all of the isotopes being bromine 79, all the isotopes being bromine 81, and when we take 3 times 79 plus the 31 for the phosphorus, we get 268. When we take 3 of these, that's 243, plus 31 is 274. Then we got the in-between ones, in which either, first of all, we have 2 79, so 181, or 179, so 2 81s. And again, if you do the permutations of all of these, you'll find that it's a 1 to 3 to 3 to 1 ratio. Easy way to think about it would be obviously here, every single one of them has to be bromine 79. When we got this one here, the bromine 81 can be the first bromine or the second bromine or the third bromine. So that's 3 possibilities. This one here, the 79 bromine, can be the first bromine, the second bromine or third bromine. So again, 3 possibilities. And finally, 1 possibility in which all of them are bromine 81. The ratios, how well you get the 1 to 2 to 1, the 1 to 3 to 3 to 1, depends upon your maths. But hopefully you can, without the maths knowledge, just looking at the arithmetic, understand the peak values, the 268, the 270, 272, 274, as exemplified here.